first theorem in the book about manifolds without boundary was that the product of the Cartesian product of two manifolds without boundary was a manifold without boundary, and its dimension is the sum of the dimension of the two manifolds. Okay, so is the same true for manifolds with boundary? Maybe you pause for a moment and think about if both factors have boundary. Is it true? Find an example of two manifolds with boundary and see if the product is still a manifold with boundary or not. What if one has a boundary and one does not have a boundary? Same question. Okay, once you have played around with this, here's the easiest example. Two manifolds with boundary, the interval, and, well, interval again. So now what's the product of those two? That's a square, so definitely something with boundary. And I know what the boundary is, namely the boundary of the square is nothing else than, well, if this is I1, I2, then its boundary is the boundary of I1 times I2 union the boundary of A2 and 1. So here we go. Okay, but is it a manifold? And, well, as a differentiable manifold, no. If you were like in a weaker category, yes, you could say it's a disk, but no, for us, differentiable it's not, because corner points. So, no, in general, the product of manifolds with boundary is not a manifold with boundary. Corner points. But, second example looks a bit more promising. If we have a manifold without boundary, for example, S1, and let's take as the one with boundary again an interval. And now I take a product. S1 cross I is, well, here's S1 cross an interval everywhere. So I'm adding up with this cylinder. And that is definitely a manifold with boundary. And what's the boundary? Well, here and here, these two circles. So, again, I can write it like this, but one of those is 0, so it's here, the boundary of the interval cross S1. So that's S1 cross 0 union S1 cross 1. So yes, here we do have a manifold with boundary. We know how the boundary is given, and the dimension is 1 plus 1 equals 2, as in the case without boundaries, as one would expect for a product. So yes,